Question 22 tells us when a bias coin is thrown 4 times, the probability of getting a heads is 16 over 81. Work out the probability of getting 4 tails when the coin is thrown 4 times. So key things here, it's bias. So the chance of getting 4 heads in a row would have just been a half times a half times a half times a half, which would be, what, 1 over 16? But this is giving a different answer. It's giving 16 over 81. So what we've got is the probability of getting heads, heads, heads is equal to 16 over 81. But if we start thinking of what this would look like in a probability tree, if I start down here, I've got plenty of space. My first flip of the coin, I could get heads, tails. The second flip of the coin, I could get heads, tails. I could get heads, tails from there, and so on. Okay, now I could keep on repeating this, but because I'm only interested in heads, 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 and then getting 4 tails, so I'm going to be trying to work out down here the probability of getting tails, 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 then I can just start to disregard these branches here. So I am just going to come off and say what the options were here, but I'm only interested in very specific paths, which is repeatedly getting heads or repeatedly getting tails. So I'm just going to ignore these combinations here, okay? But you could draw it if you wanted to go, but I would have found that I probably squeezed everything up, so I can cancel out those ones there. Now effectively, this 16 over 81 is telling me this solution here. This is a number, which I don't know what it is, so I would say x, times by another number, x, times by another number, x, times by another number, x. They're always the same because it's a biased coin. It will always have the same probability of flipping to a heads, equals 16 over 81. Well, what I'm doing then mathematically is saying x times x times x times x, or x to the power of 4 is equal to 16 over 81. Then in order to find out what x is, what is this number here, what is this fraction, I want to do the 4th root of 16 over 81, which is the inverse of to the power of 4. So from here now, I can pop that into my calculator, although this might have been a non-calculated test, so we'll go through that as well. So 16 over 81, if we did have a calculator, tells me it's 2/3. If we didn't have a calculator, you're thinking what number times by itself 4 times is 16, and the same with 81. So if you just work through your numbers, 1 times 1 times 1 is obviously 1. 2 times 2 is 4, times by 2 is 8, times by 2 is 16. 3 times 3 is 9, times another 3 times 3 is also 9. 9 times 9 is 81. They're never going to make these the most horrendous numbers. So although I've jumped and picked up a calculator straight away, I just want to show you how to use the 4th root. You can easily work this out without a calculator. So if x is 2/3, that means tails must be 1/3, and 1/3, and 1/3, and 1/3, and so on. So this must be 1/3 to the power of 4. So therefore, it would be 1 over 81.